Hi everyone. Okay, so this is a new topic for chapter 4, three gases law. Today we just concentrate about calculation only. Okay, no theory. So what you need to do is memorize the name and formula for the three law. Alright, so next. These are the three gas law. Gay-Lussac number 1, Boyle's law. That is Charles' law. Boyle's law, Charles' law. Okay, so this triangle will help you to memorize their formula. So normally I would draw an inverted triangle first. Then I remember Gay-Lussac. Last time we say Gay-Lussac is as a pressure law. So I will remember in this way, persatuan, pressure, I remember as persatuan. B means bahasa, C means China. Okay, so always start from the bottom of your left hand side. Persatuan Bahasa Cina. Persatuan means pressure law, Gay-Lussac. Number 2, Boyle's is bahasa. Number 3, China means Charles. So, Gay-Lussac law, we look at the left hand side. P over T means pressure over time. P means pressure. V means volume. Oh, over time. Sorry. It's temperature. Okay, so means the three variables of the gas. Pressure of gas, volume of gas, and temperature of gas. So when we study these three, we will look at two variable only. When we study about PT, means volume is constant. When we study about PV, means temperature is constant. When we study about V over T, means pressure is constant. Okay, so now these are the three formula for the three gas law. You can pause it for 1 minute. Then you use a paper. If you can draw it out, means you really can memorize already lah. So I'll stop 3 seconds. You pause, then you restudy this. Okay, then 1, 2, 3. Okay, next. Temperature of scale is like this. Before this, we always use Celsius scale, 0 to 100 degrees Celsius. And Kelvin scale is standard SI unit. Actually, 1 degree Celsius equals to 1 Kelvin. But the scale is different because the absolute zero means really no temperature is called 0 Kelvin. This is not okay, but 0 Kelvin. So absolute zero actually is negative 273 degrees Celsius. Okay, so means increase of 1 degree Celsius means increase of 1 Kelvin. Okay, but The 0 for Celsius is 0 degrees Celsius. And actually the absolute zero, really no heat, is called 0 Kelvin, which is equals to negative 2730 degrees Celsius. So if you draw the graph will be like this. If this is temperature and this is volume, so temperature in degrees Celsius, then we will get negative 273 degrees Celsius, which is the zero, of the Kelvin. Okay, this is in the experiment Charles' law. So we will, when we go back to school, we will do this lah. Okay, and okay, so now what you need to remember is when we get a temperature in degrees Celsius, if we want to change to Kelvin, we plus 273. If we want to change Kelvin back to degrees Celsius, we minus 273. That's it. Okay, for example, 27 degrees Celsius means 27 plus 273. So would be 300 Kelvin. Okay, if 30 degrees Celsius, if we want to change to Kelvin, 30 plus 273. Answer would be 303 Kelvin. Okay, so all of the temperature we need to change to Kelvin scale, SI unit. Now ready? I count 1, 2, 3 and get to the next slide. 1, 2, 3. All right, so now a metallic cylinder contains gas at pressure 280 kilopascal and temperature 47 degrees Celsius. What is the gas pressure if the temperature of the surrounding decreases to 27 degrees Celsius? Okay, so as we know, how to solve questions, I always encourage use IFS, which is info, then formula, then substitution. All right, so now write info first. We got gas pressure 280 kilopascal. I encourage you change your kilo into index form times 10 powers of 3 Pascal at temperature 47 degrees Celsius. What is the gas pressure if the temperature of surrounding decreases to 27 degrees Celsius? What is the gas pressure? So actually here got two sentence, means there are two conditions. Sentence 1, 280 47 means this is condition 1. Sentence 1 means condition 1. Sentence 2 means condition 2. All right. So now what is the formula? The formula can be determined by using the triangle PV over T. You can see we have P, we have T. So actually it is Gay-Lussac law. So let's see, it will be P1 over P2 equals to P2 over T2. Oh, sorry, this is 1. This is 1. Condition 1, condition for P1 T1 equals to condition of P2 T2. And don't forget, our temperature should change to Kelvin. So it's 47 plus 273, and we will get 320 Kelvin. This one plus 273, and we will get 300 Kelvin. Now, everything is there. Let's substitute. So 280 times 10 powers of 3, because kilo, divided by 320 equals to P2 as unknown. T2 is 300 Kelvin. I encourage you to don't write the unit so that you will not confuse with the unknown. So now what should we do? P2 is unknown, so we cross multiply up 300. So P2, I put it on the left hand side. P2 equals to 280 times 10 powers of 3 divided by 320 times 300. So answer, please press your calculator. So answer will be 262,500 Pascal. Or if you want, you can write in 262.5 kilopascal. Or you can write in index form 2.625 times 10 powers of 1, 2, 3, 4, 5 Pascal. Yes, pressure unit is Pascal. Now, get it? I encourage you to post this, then you rewrite, you redo this. Okay, you redo this. Okay, post and redo. Okay, 1, 2, 3. Next slide. All right, so now before the start of a journey, the air pressure in the car type is 2 times 10 powers of 5 Pascal, and the temperature is 27 degrees Celsius. At the end of the journey, the temperature of air in tire becomes 77 degrees Celsius. What is the air pressure in the tire? So IFS. Air pressure is in the beginning 2.0 times 10 powers of 5 Pascal. P1. Temperature 1 would be 27 plus 373, since we want the Kelvin, 300 Kelvin. All right, so next, P2, don't know what is, but we know T2 is 77, so plus 273 will be 350 Kelvin. So now, what is the law? PV over T. Yes, still Gay-Lussac law. So our formula will be P1 over T1 equals to P2 over T2. So P1 would be 2.0 times 10 powers of 5 divided by 300K. P2 don't know, let it be unknown. 350. So P2 equals to the same thing, cross multiply up 2.0 times 10 powers of 5 divided by 300 times 350. So it would be 333.3333 Pascal. Or you can make it as 2.33 times 10 powers of 1, 2, 3, 4, 5 Pascal. Alright, so I have substitute S, then solve it, done. So make sure your formula you refer from the gas law. Okay, 1, 2, 3. Now, a hand pump contains 12,000 centimeter cube of air at pressure 100 kilopascal. Centimeter cube actually means volume. Then pressure lah. Pascal means pressure. Okay, so this is P1 V1. The mouth of the pump is then closed and the piston is pushed so that its volume is reduced to 750 centimeter cube. Calculate the air pressure in the pump. So this is P2, this is V2. So let's see. P1 equals to 100 kilo times 10 powers of 3 Pascal. V1 equals to 12,000 centimeter cube. P2, let it be unknown. V2, 750 centimeter cube. So first info. Second formula. What's the formula? It would be PV over T. So see, we got P, we got V. So this is Boyle's law. Boyle's law. So we say P1 V1 equals to P2 V2. So P1 will be 100 times 10 powers of 3. V1 will be 12,000. P2, let it be P2. V2 750. So solve it by using the linear equation. So it would be divide down here. So it will be 100 times 10 powers of 3 times 12,000 divided by 750. So P2 equals to 160,000 Pascal. Or you can write as 1.612345 times 10 powers of 6 Pascal. This is index form, standard form, or you can just copy on. Alright, so info formula from the PV over T. Substitute, solve, answer. So IFS info formula, substitute, solve it by linear equation. Alright. So 1, 2, 3. Next slide. Number 4. And number 4. Okay. A syringe contains 5 ml of air at room temperature 27 degrees Celsius. The syringe is then kept in the refrigerator and its temperature decreased to 3 degrees Celsius. What is the volume of the air in the syringe? So ml actually equals to 5 ml equals to 5 centimeter cube. Means what? Means its volume. Then degrees Celsius, of course, temperature. So see, this is V1, T1. So this is V2, T2. So let's write down info. V1 equals to 5 ml can, cm cube also can. T1 equals to 27 degrees Celsius. Don't forget to change to 273 plus 273 means 300 Kelvin. So V2 equals to, don't know, let it be. Then temperature, second temperature would be 3 degrees Celsius plus 273, and we will get 276 Kelvin. Then next, what to do? Yay! Please draw the triangle to check which formula is used. Okay, so we got V and we got T, means we are using Charles' law. Oh, sorry, it's Charles' law. Now, formula will be V1 over T1 equals to V2 over T2. Alright, so V1 will be 5, T1 will be 300, V2, don't know, let it be, T2, 276. So what should we do? Cross multiply up, then left, right. We always put our unknown on the left. At the end, we put unknown on the left-hand side. Unknown. So 5 over 300 times 276. So it will be 5 divided by 300 times 276. That will be 4.6 ml. Volume is ml. Means what? Means temperature decreases. Temperature decreases. Volume also decreases. Alright, info, formula, IFS, then substitute, then solve. Right? Formula comes from the triangle. P over V, Gay-Lussac. P over T, Gay-Lussac. P times V, boys. Gay-Lussac, boys, and Charles. Okay, so today we just learn how to calculate how to use the formula. That's it. Okay, so 1, 2, 3. Let's look back. Number 1, we learn Gay-Lussac, P over T. Number 2, we also learn Gay-Lussac, P over T. Number 3 is Boyle's law, P times V. Number 4 is Charles' law, V over T. All right. So next, I'll show you how to solve your Tugasan 3 in page 120. Okay, so now a piston is pushed from A to B. From A to B means A is longer, B is shorter. Find the original length, Y. If the pressure changes from 10 Pascal at A, 10 Pascal at A, and 18 Pascal at B. So P1, 10, P2 is 18 Pascal. So what can we do? Now P1 is 10 Pascal, original. So what is Y and what is 5 cm? Seems like it is length, Y cm. And actually this can represented by volume. Volume equals to A times L. Agree? Area times length. Since the area doesn't change, area 1 and area 2 doesn't change. Okay, so we can directly treat length as volume. we can treat length as volume. So length 1 actually is V1. Then P2 is 18 Pascal. 18 Pascal at B. So V2 actually is 5 cm at B. So this is condition A, condition B, 1, 1, 2, 2. So in 4 we have done. Next, what should we do? Formula. If we want to know what's the relationship between P and V, draw out the triangle PV over T. We got P, we got V. Means we have Boyle's law. We are applying the Boyle's law. So let's write P1 V1 equals to P2 V2. So P1 equals to 10 kilopascal times Y equals to P2 would be 18 Pascal times 5. So Y will equals to 18 times 5 divided by 10. So Y equals to 9 cm. Okay. So from here we apply back what we have learned in maths. Volume equals to area times height, the length. So we can treat length as volume. Then the rest is the same. I, F, S, substitute and solve. All right. This is in your module, page 120. Please do not copy, but do it yourself. Don't copy. All right, so 1, 2, 3. Next. All right, an air bubbles rises to the surface from the seabed. What is the depth of the sea if the atmospheric pressure equivalent to 10 meters of water? Okay, so this one involves another concept. Okay, means pressure. Pressure means 1 times 10 powers of 5 Pascal. Pascal is SI unit. Then this 1 times 10 powers of 5 Pascal actually means the pressure also means if you dive in the sea 10 meters below, the pressure here would equals to 1 times 10 powers of 5 Pascal of water. Okay, so we also can say that atmospheric pressure equals to 10 meters of water H2O. So we can say air pressure as Pascal. We also can say air pressure, atmospheric pressure is 10 meters of water. If you dive 10 meters of water, dive in the depth of water 10 meters, you will experience the same atmospheric pressure. So we also call atmospheric pressure as 1 atm or 1 bar. You can look at the back of your watch. You will see 5 bar, means you can dive in 50 meters of water. Okay, so far understand this? Pressure can write as Pascal or can write as 10 meters of water. Okay, so now they say, what is the depth of the sea if the atmospheric pressure is equivalent? Okay, so now we look at the bubble first. The bubble at a seabed actually is smaller. Why is it? Because here got higher pressure. Here got atmospheric pressure plus atmospheric pressure 10 meter of water plus h meter of water. But this one, when the bubble comes up to the surface, it only experiences atmospheric pressure 10 meters of water. So now let's see. Let's write the info. Okay, so first V1, you can see rises to the surface from the seabed. So this is V1, this is V2. Case 1 at the bottom, case 2 at the surface. So V1 is 0.05 centimeter cube. Then V2 is, maybe you want to write at the bottom because here you may want to write P1. V2 would be 1 centimeter cube. P1 will be the pressure at the bottom. P1 will be at the pressure of the bottom, means 10 meter of water plus h meter of water. So we can write in a short form 10 plus h. See, I say I prefer you all don't write the unit because of, you can see the unit and the unknown. Unit and the number. So seems confusing. So we don't write the unit here. We just write 10 plus h. So P2 would be 10 meter of water only. Okay, 10 meter of water. See, we got P, we got V. Means we are using correct. Boy's law. Boy's law. So now P1, V1 equals to P2, V2 equals to P1 is 10 plus H. 10 plus H. V1 0.05. P2 is 10. V2 is 1. So what is the depth of the sea? Means the H. So H is the depth of the sea plus H. So now let's solve it. 10 plus H equals to 10 times 1 divided by 0.05. So H will equals to 200 minus 10. So H equals to 190 meters. So this H is 190 meters. Now, get it? You can post it and you redo. Okay, actually it's still the same thing. Info, formula, substitute. Info, formula, substitute, done. The tricky part is what? Tricky part is now the pressure is not more Pascal, but they use 10 meter of water to replace. Okay, because one atmospheric pressure is 1 times 10 power of 5 Pascal, and these questions, this pressure actually equals to 10 meters of water. So we just change pressure as how many meters of water. That's it. Okay, then we just substitute P1 V1, P2 V2, then solve it, done. Okay, so 1, 2, 3, next slide. Okay, so your homework today, please do page 124 and page 128 for tugasan 4 and tugasan 5. So that's all for today. Thank you everyone. Bye bye.